all right, guys, all right. Welcome to Frank Teaches MLOps. Yeah, my lovely viewers. Yes, guys, yes, we are on the right path. All right. So today we will be looking at KServe. Yeah, you heard me right. All right. K what? KServe. K means Kubeflow serve. Before the original name of KServe was KFServe, KFServe, which was Kube Flow Serve, all right? But it was later changed to what? Just what? K what? KServe, right? Now, what actually is KServe, right? KServe is a component of Kubeflow, all right? It's a component of Kubeflow, right? That enables serverless inferencing in Kubernetes. I know that's too high. All right, that's too high. I'm gonna drop it. I'm gonna drop it. Okay. All right, we're still recording. Let me take it one more time. KServe is is one of the components of Kubeflow. I will be abbreviating Kubeflow with KF. All right. One of the components of Kubeflow that enable serverless serverless inference, underline the word inference, inferencing, inferencing in what? In Kubernetes. Inferencing, all right? Now, serverless means we use KServe to deploy model into a Kubernetes cluster without any form of infrastructural setup. I'll explain further, guys. Right? The term KServe is a very important tool, right? Feature in machine learning operations. Right? However, at the same time, it seems to be very um strange. All right, or the understanding of KServe, if you are not properly um guided, all right, you might miss it, right? Now we underline the word inference, inferencing. Now, what is inferencing? Inferencing in ML, in machine learning, right, is a process of using a trained model to make a prediction, to make um a what? Prediction. Now, you have a model. When you use a trained model to make a prediction, that process is what we call what? Inferencing. And KServe enables serverless inferencing in what? In Kubernetes. Serverless inferencing. Now, there are other forms of inferencing, right? Other forms such as when you dockerize your model as a Docker image, right? And you deploy the model as a Kubernetes, as a container or as a pod into a Kubernetes cluster. That model could be used, right, to make prediction. That model could be, that model is termed as an inference, right? An inference. However, such a model is not serverless. That's the angle I'm trying to come from now. Such a model is not serverless because the model was created out of a Docker image. Right? Based on the Docker image, you created a pod, which we further use it to create a prediction within what? The Kubernetes cluster. Now, but in the context of KServe, you do not have anything like Docker. There's no Docker. All you have is your model saved as an artifact on an external storage. So what you do now, you will deploy the model into Kubernetes cluster as an inference service. Guys, don't worry, don't worry. No, don't worry. This is just the intro. We are getting further. All right. So we've seen what a KServe is and what inferencing in machine learning is all about. Now let's now look at the architecture. All right. But before we go, let's look at the architecture, all right, of KServe. However, before we go into even the architecture, let's still look at okay, let's go into the architecture um of what's it called? Of KServe. So this is a typical architecture of KServe. I'll explain, guys. All right. Okay. Now, let me start from the bottom. Let me start from bottom top. Bottom top. All right. Bottom top. Now, from the bottom, we have different infrastructures. Right. You have different chips. The chips on your infrastructure, on your device. You could be using NVIDIA GPU. You could be using Intel CPU, or you could be using AMD APU. So GPU is graphics processing unit, all right? CPU is basically for your general purpose computing, central processing unit, and APU is accelerated, all right, processing unit. So accelerated processing unit is a combination of both GPU and CPU, right? So in here you have a single chip, right? Let's say you have a single chip that combines CPU, the functionality of CPU, as well as functionality of what? GPU. This you can call your what? You can call it your what? APU, which is accelerated processing unit, right? So either of these could be your chip, right, on your infrastructure. Now on that infrastructure, you are setting up what? Kubernetes, right? You're setting up Kubernetes. Could be from EKS, AKS, GKE, on premise, as the case may be. On Kubernetes, you have installed two services, two major services. One is Knative, and the other is what? Istio. Now, what is Knative? Kubeflow native or Kubernetes native. All right. So Knative is an open source project, right, that enables serverless workload to be deployed on Kubernetes. Let's get the definition somewhere. Knative. This is an open source project that enables serverless workloads to be deployed, right? To be deployed into a Kubernetes what? Cluster. Now, because we need to set up KServe, KServe, which is a serverless inferencing, which is used for what? Serverless inferencing in Kubernetes. We need a platform, right? We need a platform for KServe to operate. And that platform is what? Knative, right? Great. Now the other is what? Istio. Istio, you all know, is for service merge. Istio also provides, can use Istio as your ingress controller, right? Ingress gateway and all of that. So because we need Istio to expose our services, right? To expose our services that runs um, um, within Kubernetes. Now, after that, we now have what? On top of that, we have what? The KServe. Now, KServe, I can see, is predictive and generative model inference. That's the job of KServe, right? It's used to enable serverless inferencing in what? In Kubernetes, right? Then finally, KServe has different level of abstraction, right? So these are a different level of abstractions that are supported on KServe. We have Hugging Face, we have PyTorch, we have TensorFlow, we have Scikit-learn, we have Light GBM, etc., etc. And upon that, we also have pre-processing, post-processing, prediction, generate, inference graph, explainability, and finally monitoring. Now, on your right hand side, you can see model storage. Like I mentioned, right? When you're using KServe to deploy an inference service, your model artifact will be stored on an external storage. I have the diagram, right? Don't worry, I will explain when I get there. All right. So your model artifact, which is your .pk file, which is your model.pickle. So your model.pickle file is saved somewhere, right? On S3. In this context, you're using AWS. So it's saved on S3. So all KServe needs to do is KServe needs to reference the path. It needs to reference the path to this file within Kubernetes. And that's all, guys. That's all. That's how you get to deploy your model as an inference service inside of what? Your Kubernetes was cluster. So this was what? The architecture. Now let's scroll down. Let's go further. Now, this is what we all already know. Let me now explain. This is conventional model deployment. Now, in a conventional model deployment, you have your code base on GitHub, all right? Your ML code base, you have your model.py. So this is where you've created your model, all right? You have your Docker file, you have your Kubernetes manifest, you have your Jenkins file. All right. So now you've written your Jenkins pipeline. Jenkins pipeline is going to get the code base, it's going to Dockerize the model.py file, which is your model, right? As a Docker image, and publish Docker image to your what? Container registry. It publishes Dockerized model as a Docker image. So Docker Hub, right? Now, as part of that process, right? In this model.py, okay? So remember, we already have S3 bucket somewhere here that has our data set. So our data set is pulled into our work process and is being used to build the model. Right now, data set is being pulled. Let's show that arrow. So data set is pulled, right? The data set is pulled. Let's show that arrow. Is pulled from S3, right? It's pulled from S3, and it's used to what? To build your model. Your model has been built. Now the artifact of the model has to be saved in what? In storage. It builds model artifacts, all right, to be saved in what? On S3. So your model is now saved as a model dot what? Pickle file, and is saved on what? Your S3 bucket. Great. Now, as part of your CI/CD work process, all right, you have your manifest. In this manifest, you are going to pull this image, Dockerized image, pull it, use that, and deploy a pod in your what? In your Kubernetes what? Cluster. All right. From there, you can now start making what? Inference. Right. You can now start making prediction. So the model will now be deployed into your Kubernetes cluster. All right. And based on that, you now what? Create, use that inference, right, to make what? Prediction. You now use that, right? Inference to what? To make what? Right? Which is the inference, all right? Which is the inference, all right? The trained model, let me say the trained model, all right, will now be used to what? Make what? Predictions. Will now be used to what? Make what? Prediction. That's it. So this is a conventional flow, which is serverful, right? However, this is too tedious. Tedious in the sense that I have to do all of these, Dockerize, write pipeline, do this, push. Finally, I will deploy. It's too tedious. KServe is going to make all of this process very easy. Just one command. KServe has deployed your model into your Kubernetes cluster as an inference service. Let's look at how KServe is able to solve this problem. It's not really a problem, but it's a smart way of deploying model into your Kubernetes what? Cluster. All right. It's a smart way of deploying model into your what? Kubernetes cluster. Now, how is KServe simplifying model deployment? Let's look at that. Now, remember, I have my CI/CD. I've used my CI/CD. I have built my model. I've built my model, right? Now, I'll now what? Automate the publishing of the model artifacts to my S3. All right. So I have my model artifact now. Model the what? Pickle. All right. Now, I'll now go to KServe. I will install KServe with the necessary supporting serverless options like knative, istio, etc. So in short, when you install KServe, KServe comes with a whole lot. It comes with istio, it comes with knative, etc., etc., and KServe itself. All right. So I'll get that installed on my cluster. Now, once it's installed, now I need to use KServe to deploy this model that is hosted on what? S3. Now I'm going to write an inference service, right? Simple. I'm going to write an inference service. And in that inference service, I'm going to reference this file, this artifact. I'm going to do what? I'm going to reference this artifact. So KServe will be given the permission to download this artifact and deploy it in my cluster as an inference service. Now, once it has been deployed as an inference service, right? I will now what? It will expose for me, it will create for me an external IP, which I will use, right? Right, with the help of istio, right, to make predictions, right? Because the trained model is what I have deployed as a service, an inference service. And with that inference service, I can start now making what? Predictions. So this is the flow with what? KServe. right? So that being said, let's now get started, right? So for today's video, I'll be making use of Kubeflow um, set of data, all right? Not using Kubeflow set of data. I'll be making use of Kubeflow example, all right, to show us how you can get started with KServe. However, after today's video, all right, I have my own model which I've already built and published the artifacts to S3. After today's video, I will use my own model to make a different video, right? So I can see the difference. All right. So great. But today is just to get you familiarized with KServe. All right. So you get comfortable using what KServe within your production environment. So for that, I'm going to go to kubeflow.org. Kubeflow, kubeflow.org. Kubeflow. So under Kubeflow.org, I'll click on this arrow, it takes me down. All right. Then I'll see what KServe, which is used for what model serving. What basic KServe is, right? It was previously known as was KFServing. It solves production model serving on Kubernetes. It delivers high abstraction and performance interfaces for frameworks like TensorFlow, XGBoost, Scikit-learn, PyTorch, Onyx, etc., etc. Now let's click on what KServe. So if I click on KServe, now you already see I have what the architecture down here. It says what is a highly scalable and standards based model inference platform on Kubernetes for trusted AI. All right. So why KServe? KServe, maybe when you have time, guys, you can just go through it. All right. Go through it, read about it, and okay, KServe components and predictive inference, generative inference. All right. It has a lot of application. All right. It has a lot of application. That being said, let's click on what get started. Now, on my left hand side, I have what KServe quick start. First inference service. Interact with inference service Swagger UI. All right, let's get started. First thing first, we need to set up a Kubernetes cluster, right? So I have set up my Kubernetes cluster, which I have here. So this is my Kubernetes cluster, right? Which is running on what? EKS, AWS, right? Now, we also need Helm. Now, look at this flow now. This is my control machine. From this control machine, I am talking towards my Kubernetes cluster. On this control machine, I'm going to install I've already installed Kubectl. I'm also going to install Helm. I already have AWS CLI. What else? All right. So I think those are the few things I have. Now let's install Helm. Now, to install Helm, I'll right click on this link, new tab. So I'll install Helm as a script from a script. So just copy this M3. Did I copy that? No. Oh, copy. All right. Done. Then, oh, sorry. Go back. Then change permission. That's it. Then finally get him working. All right, so Helm has been installed. So if I type Helm, I should have that. Okay, we have Helm now installed. So close the page. So we install Helm. Now the next thing is, yeah, we've installed Helm on our cluster. Now we need to install KServe. Look at now. You can then get started with a local deployment of KServe by using KServe quick installation script. All right, so this is the quick installation script. So we have KServe versions. You can see currently I'm running on KServe version 15, right? So if version 15 doesn't work for you, you can try 14. 14 is more stable, right? I tried 14, I tried 15 on kind, it didn't work. So, but when I tried 15 on EKS, it worked out of the box. All right. So I'll be using what version 15. Okay. So I'll just copy this. All right. Copy that. Right. But before I copy that, let's see the content of this file. All right. Let's just see the content of that file. So I'll paste that. All right. So do like this. Hope you're still recording. Yeah. So I just need to download this guy. That should give me dash O, dash capital O. And yo, wow, 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 wow. Okay, I have. All right, so I got the file. So let's open the file. Quick what? Quick install. So here's the content of the file. So let me set line number so that great. You can see bash blah 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 export. It's going to be installing istio bash istio knative. Right? I said what? Knative is an open source project that enables serverless workloads to be deployed in to run in your Kubernetes cluster. All right, KFServing, KServe, certificate manager, gateway API, KDA version. All right, so it's the script has a lot of helm, and to be using helm, all right, to perform the installations. All right, using helm to perform the installations, and what else do we have there again? And to do that deployment serverless. All right. So that is the content of and that's all. That's all right. Let's escape. Good. Okay. So now let's now perform the real installation. Right. Just copy this, come over here and just paste it and hit enter and sit back, guys. So it's going to install all CRODs. All right. And it said it failed. All right. So because I already had such issue has been added to your repository. I had this before in 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 my cluster, right? So let me uninstall it. Okay. I'll do quick. Let me make these let me make that executable. All right. So now let's uninstall dash u. Everything that we did. All right. So we're going to uninstall everything and reinstall them. Okay. So everything is getting uninstalled. So let's just be patient a bit, guys. Okay. Okay. Now everything has been uninstalled. Everything has been what? Uninstalled. Let's try installing it one more time. Right? Let's try the installation. And okay. Okay. So let's just sit back and grab a cup of coffee. It takes some time, right? So here we are seeing istio ingress gateway successfully installed and istio daemon successfully installed. Okay. Mm, mm, istio base successfully installed. Okay. All the custom resource definitions. Let's wait. All right, let's just sit back, guys. Let's sit back and take some time, take some pretty time. All right. So, guys, KServe is a game changer. All right. KServe is a game changer. So, KServe saves you the stress, saves you the hassle of conventional model deployment. Right. So that's what KServe saves you from. It saves you from the conventional model deployment. You don't need to be going through all this process. All you need to do, have your artifact on your S3 buckets and reference that artifact using case Kubernetes manifest and deploy it into your Kubernetes cluster, and you're all good, guys. You're good. All right. So where are we? All right. Successfully install certificate manager. All right. Certificate manager. So jet stack. All right. Let's just wait. Let's just wait. Let's just wait. Okay. Just wait. So I am on this control machine. On this control machine, I'm performing those operations, guys. All right. On the control machine, I'm performing those operations. So KServe is a game changer, guys. Is a game changer. All right. So this is where we are. So once you're done with this, installing KServe on our server, we're now going towards first inference service. How do we create our inference service? Okay. So now look at this now. Run your first inference service. In this tutorial, you will deploy an inference service with a predictor that will load a scikit-learn model trained with the iris dataset. So iris dataset is a dataset that comes inbuilt, right, with scikit-learn. It comes inbuilt with scikit-learn. Okay. Now everything was installed. Successfully what install what KServe. You can see we have successfully installed KServe. Now let's check. So I'll say kubectl get all in what namespace? In istio system. In istio system namespace. So I'll see all my objects deployed in istio. So what do we have here? So from the pod, I have the gateway and istio daemon is running. From the services, we have the istio ingress gateway, and as it has created a load balancer. This load balancer will be shown on AWS. Let's go to AWS. Let's refresh our load balancer. We should see the load balancer. You can see here, right? Great, great, guys. All right, and then these are the deployments, replica sets, and horizontal pod auto scaler. So yeah, guys, we're good. All right. Now, the next step for us is inference service. So I was talking about the iris dataset. Okay, the iris what dataset. So the iris dataset is included in your scikit-learn dataset. Now, how do we see this dataset? But before that, let's continue. The dataset has three output classes. That being said, an iris is a flower, right? It's a flower. So it has a class of setosa, it has versicolor, and it has iris virginica. So these are the three classes of iris flowers, right? That the data set is categorized into. It now says you will then send an inference request to your deployed model in order to get a prediction for the class of iris plants your request corresponds to. All right. Now let's show us the data set. I'll go to Google and I'll type iris dataset, and I'll open this GitHub link. I'll open it. So this is the dataset. Now look at now. Here's the dataset. Now you have seplat length, seplat width, petal length, petal width. Based on the sepal length and width and petal length and width, you're going to what? Determine what plant is the iris. Is it setosa or versicolor or virginica? Based on these values, right, the model is going to make a prediction of what iris plant is selected. All right. So this is what the data set, guys. Here is your data set. I hope you're good, guys. Great. Now let's go back to our dashboard. Now we've seen the data set. It now says, since your model is being deployed as an inference service, not a raw Kubernetes service. Take note, guys. It's not a raw Kubernetes service. It's deployed as an inference service. You just need to provide the storage location. Please underline that word. The storage location of the model, and it gets some superpowers out of the box. Now, what are we saying? Come back to you now. They say you just need to provide a storage location. So here is our storage location to our what? To our artifacts. That's the only thing I need to just provide, and it will get what? A superpower what? It will get what? Some superpowers out of what? Out of the box. Great. The first thing is we need to create a namespace called what? KServe test. Let's do that. Copy this. Come over here. I'll paste that. Oh, sorry, guys. Copy. All right. So error. We already have that namespace. I say kubectl. Kubectl get namespace. We have a namespace called what? Where's it? KServe what? Test. All right. So you have to create that. Now create an inference service. This is it now. This is a new schema. This was the old schema. So what did they change? So in the old schema, they didn't add model format. All right, they just went to say predictor and specify this link. Let's look at that. Yeah, right. So this is new format. So we'll be using what? The new format. You don't need to do anything. Let me just explain this file. Now here's the API version. It's using what? serving.kserve.io / v1 beta 1. Then the kind of this object is not a conventional Kubernetes service. It's an inference service. All right. That's the kind of this object, inference service. The information, this is the name of the service, scikit-learn iris. The namespace is going to be deployed in this namespace. And predictor model format, the name is scikit-learn. Then the storage URL. Now, the owners of these data sets, right? They've used the data sets to train the model, and they've saved the model on somewhere, maybe on Google storage. The model is in this location, storage URI. You can see now. The model is in that location. That is the artifact. So now we are going to use KServe to download that model into Kubernetes and deploy it as a what? As an inference service. And based on the inference service, we're going to start making what? Making predictions. Does that make sense, guys? All right. So let's copy this. Copy all of this. So we're going to create a file and deploy it. Let's go. So I'll just paste all of that and hit enter. It tells me that error. Server could not find the request Are you sure? Okay, I'm coming, guys. Let's my CRDs were not, it's like my CRDs were not properly installed. CRDs, why? Kubectl get CRDs. CRDs, we have inference now. Okay, what we have here is inference graph. Inference graph. Why? So it's complaining of inference services dot KServe. Um, um, let's do this one more time. Let's do this one more time. Okay. Why? Don't give me this attitude. Hmm. Um. Error from this is error when creating this. The server could not find the requested resource. I would have used a what's it called? If I had known, I would have used a fresh cluster. Let's see if ChatGPT could get us out of this issue. Okay, let's see if ChatGPT could get us out of this issue. Doesn't recognize the inference service resource you're trying to create. So this is not there. Okay, that's a challenge. That's not there. Um, that's not there. Um, um, why? Because if we run this, I won't be able to get that. We're not getting it. Not found. So that's why we're having that error, guys. All right. So the CRD is missing. The CRD is missing. CRD is actually missing. Um, let's see this. Bam. Okay, let me download this file. Let me see something. Oh, I'm not going to mess up. W gets that. The file itself is not even found. Okay, so guys, let me set up a fresh cluster, all right? Because I've used that before, and I've used that before. Check which resources are available. It's not installed properly. Yeah, CRD is not installed properly. So let me uninstall those CRDs. Kubectl delete CRD. Um, or um, let's get those CRDs. Kubectl get CRD. Able deleting. Oh, okay. Um, mm, let me try uninstalling for once. If it didn't go, then let's uninstall. All right. Okay, so these were the certificates. So custom resource definition. So I need to delete this as well, so that these resources we are kept due to the resource policy. Okay, so we need to delete these guys as well. We need to get them deleted, then reinstall. I think everything should be fine. All right, so let's get this guy deleted. So kubectl delete crd. Copy, 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 and copy. All right, so just deleted those CRVs. All right, so let's reinstall. So do q that and that. So installing. I pray this should rectify the challenge. So if it doesn't, then we may have to reinstall the cluster, and yeah. So guys, let's just sit tight and let's sit tight. So like I said, so this is the iris datasets, all right, based on the sepal length and width, and the sepal length, the petal length and width. You can make your what predictions of which category does this data set belongs to, right? Of which plant, right? Is it a setosa? Is it very what vesicolor, or is it virginica? All right, great. All right, so this is where we are. So let's just wait, guys. Let's this thing just finish whatever it's supposed to do. All right, let's just finish and let's wait. So the inference service is not a conventional Kubernetes service, all right? So yeah, so that's what we want to deploy now. So we're having this error because the custom resource definition for the inference service is missing, right? Is missing. So let's just wait. Let's just wait. Knative operator, yeah, successfully installed. Okay. KServe CRD. Okay. Oh, we didn't get any error. Yeah. Now the images are getting pulled. Okay. For KServe version 15. I think we should be fine now. I have that feeling. Let me check the old one that we did. Old one that we did. Old. KServe. It's all the same thing now. Install KServe. Let's see. So you pull this image. All right. So it said successfully what install KServe. So let's check the CRD. So kubectl get CRD. We should see that inference something. Now it is coming. Now you can see it, guys. Inference services.serving.kserve.io. So this should work. All right. So initially we had what inference graphs. We didn't have the inference service. Now we are good now. Now if I come here now, copy this guy, all right, we should have a seamless inference service deployment. All right. So this should tell us now this guy is now created. So guys, you can see how we were able to resolve our issue. All right. So you have to uninstall and reinstall. All right. Great, guys. So I can now say kubectl get iService. So this is not a conventional Kubernetes service. So conventional Kubernetes service is what? SVC, right? SVC. But this is an inference service. So I'll say what? ISVC, right? So there we go. It says resource not found. In which namespace? It has to be in what? In the KServe test namespace, because that is the namespace that we deploy it into. You can see KServe what? Test namespace. So let's go there. What is it giving me? You can see, yeah. So our service is now up. You can see. So this is service name. The URL is this, right? The ready state is true. Latest is 100%. Pre what? That. Latest ready revision is that, right? Okay. So yes. So now let's continue from here. So I'll now scroll. It says what? Do not deploy inference services in control plane namespace. All right. That's just a warning. But it's already here. We have to deploy the inference service in a separate namespace, all right, other than the namespace that has a control plane. That's okay. Step 3, check the inference service status. So which you've done, right? You can copy this. We've already done it, guys. Right? You can paste it. Which you've done already. So I copy this, come here and paste, right? We have exactly the same way it is here, right? Same way it is here. Now, step 4, determine determine the ingress IP and port. Now, when I check this istio ingress gateway, let's copy that. Copy that. So in my own context, what I have is just a a load balancer, right? Not an external IP per se, right? I can see this is what an external IP as a what? A load balancer. So this is our host name, right? Now, so but in their case, they have what? An external IP. Now, we need to now what? Expose um the endpoint so that we can use our data, our information to start making predictions. All right. So I'll select load balancer. It says if the external IP value is set, your environment has an external load balancer that you can use for ingress gateway. So we want to use what? We want to set up our ingress gateway. So what I will do now is I'll copy this first line. So what is this first line doing? What is it doing now? It's trying to extract the what? The external IP, which is this IP, the ingress IP of the load balancer, of what? Of the load balancer. It's trying to what? Extract this IP. But in our own case, it's not going to be IP. It's going to be what? Host name. Now, ordinarily, if I bring out this command, let me show this command. This command, copy it. Oh, all right. Copy. Come to your cluster. Sorry. Copy. Come to your cluster. Paste. Now, I remove this part, right? So this should return nothing. Why? Because there is, oh, sorry, there's a mistake somewhere. All right. It returns an empty string because there's no what? External IP. What's there is just a host name. So I'll replace that with a host name. Host name. And it returns, what are you seeing? It's returning what? The load balancer endpoint, right? Here's what? Load balancer endpoint. Okay. So what we'll now do is we're going to edit this guy, right? Copy that. So you're passing that as an environment variable, which is the ingress host. Our ingress host has our load balancer, right? So the ingress host has our load balancer endpoint, right? Copy that, paste it, and in here we just put our what? Host name, host name. Enter. we have that. All right. So if we say echo echo ingress underscore host, it should throw up what the, can you see, it throws up what the load balancer endpoint. They'll do the same thing for the port. The port should be port 80 thereabouts, right? So come over here and paste that, right? So without this, we could just get the port. Let's see how we can get the ports. Let's see how we can get the ports. The port returns HTTP ports. All right, all right, all right, all right. So let's do this into, okay, and there we go. There we go. Now scroll to the bottom. Step 5 say perform the inference. Now you need to perform the inference. So these are the given data, right? These are the input data. So based on the input data, we are going to determine which class of iris plant does this data set belong to, right? Which um class of what iris plant is this data set belongs to, right? Great, great guys, great. So let's get started. So it's going to create an input.json file. So copy that, right? That's my input file, right? So I paste it. I've created my input file. My input file is what iris input.json. So that's where I have my data set. Now, I'll now come, depending on your setup, use one of the following commands to call the inference service. So, I want to call the inference service, right, to make predictions now. Now, as you can see now, we're using call, right? Okay. To what? To call the inference service so that we can start making what prediction. You can see the file here, iris input.json, right? Now, what I'll do, I'll come from ingress gateway with host header. This is the option I'll take. Just copy it like this. Copy, copy. Come over here. Let's copy again. Copy. Come over here. Paste that and hit enter. The moment I hit enter, you can see Viola. It has given us the prediction. Yes, let's start from the top. The top says our host is this on port 80. It was resolved. All right. And it was connected to the load balancer. All right. And it did a post, right? A post request. Okay. And the response was okay. Okay. And finally connected to this endpoint. And here's the prediction, guys. It predicted that 1,1. And from this data set, right? Zero is Setosa. Zero is Setosa. One is vesicolor. And two is Virginica. Right? Now, from the predictions that we got now, it tells us that the type of iris plant is vesicolor, right? The type of what iris plant is what vesicolor. Now let's go and modify the iris this file. Let's modify this file now, right? Let's change one of two things. Let's go to Virginica, right? Sorry, it is Virginica. No, Virginica is 2. Vesicolor is 1, so it's 1, right? So let's try and use Virginica data, right, in here. So I'm going to take 64, 72, 28, 30, 5.6, 58, 2116, right? Based on that, let's see how the prediction will work. So this will be 64, 64 by 72, 7.2. Okay. The next one is 3.0, 3.0 by 2.8. Yeah, we are good. Next one is 5.6, 5.6 by 5.8, 5.8. And the last one is 1.6 by 2.1. Okay, sudo one. Good guys, right? Good. Let's save this file and exit. Escape, save and quit. Save. Now let's make our prediction now. Let's come back here and then copy this guy and see what our prediction will look like. Remember, the first prediction we made was what 1,1, right? So which gave us what vertical. So if I do this now, you have something else. You can see now we are getting what 2,2. So this tells us that the type of iris plant is what is Virginica, right? Is Virginica. Like I said, Satosa is 0, versicolor is 1, Virginica is 2. That being said, guys, you can see how we've been able to what use what KServe, right? To use KServe to what to deploy our what machine learning model within the Kubernetes cluster as an inference service, right? That being said, guys, at this juncture, I want to bring this session to a close, all right? And hope to see you in my next episode. In my next episode, right, I'll be making use of my what of my own data, of my own model, right, of my own model, which will be hosted on AWS S3, right? So we're going to see how that plays out. Until then, I want to say bye bye and thank you for having us. Yeah, thank you and have a lovely day ahead. Peace out. All right. Um, to wrap it up, just to wrap up, okay? Take notes. Just to wrap it up, we said, what's KServe? So KServe is an open source project, right? That does what? That is used to enable serverless inferencing on Kubernetes. And what do we say an inference is? An inference is a machine learning. In machine learning is a process of using trained model to make what predictions. Now I have my inference already deployed, right? Based on my inference, I'm using a trained model now to make a what a prediction. Can see how we made what that prediction. Then there's the architecture of KServe, right? KServe uses knative and istio. Knative is a platform that supports, that enables serverless workloads to run on Kubernetes. And KServe is a what? It's a serverless workload. All right, great guys. So it's been very, very informative session. And why KServe? But before we talk about why KServe, there was our conventional model deployment, where we explain how you can Dockerize your model, publish it as an image to your container registry, right? And deploy it into your Kubernetes cluster and make an inference out of it. Okay, and use that inference to make a prediction. Okay, great. Now, how is KServe simplifying the model deployment? How is KServe simplifying model deployment? So this is the workflow, guys. This is the workflow, right? So that being said, thank you guys. Thank you and see you in our next episode. Peace out. Good night.